Hello everyone, and welcome back to another mathematics and GIS lecture video. And in this video, I want to go through quickly an example of what a slope-intercept equation looks like for a line using actual values. So instead of that sort of generic y equals mx plus b we talked about, let's use some actual values in here, and let's look at the corresponding line that equation equates to. So we have the equation here, y equals 1/2 x plus 2. And we had mentioned before here that in this equation there are sort of two components. The first component is this 1/2 here, which is the slope. And the second component here is this, let's use blue, is this 2 here, which we said was the intercept. Right, and this is the slope-intercept equation. And we had mentioned in the last video that what the whole point of this equation was if you have an x, to relate it to its corresponding y. And we said it did that with the slope, which we said was what happens to y when we change x. And the intercept, which we said is where does the line cross the y-axis, or conversely, what is y when x equals 0. So let's take a look at the actual line here. So this is the line that is expressed in this equation. And let's look and see what this slope here means first. So when we mentioned slope, right, we said that slope was the chain, was how is x related to y, or more precisely, what happens to y when we change x. And I threw out a bunch of different terms: rise over run, change in rise over change in run, delta y over delta x. But I think the easiest way here is to say what happens when we change 1 unit in the x, what happens to y. So let's go ahead and pick our first x here of 1. Right, so if we have x equals 1, we go up and we go over. So let's say when x equals 1, y is supposed to be equal to 2.5. Right, you can see that's pretty accurate here. So when x equals 2, right, when x equals 2, right, we've changed this, yet when I have a y value, so we're going to draw over to the y-axis, right, y equals 3. So you can see here that with a change in x of 1, y only changed by 1/2. So if you do the math there, right, change in y, which is 0.5, over change in x, which is 1, equals 0.5. Now, if you didn't follow this, that's okay. We're going to have an entire video talking about how we can calculate slope in a variety of different examples. But the idea here is that what this slope is saying is if we change x, how much does y change? And I find it's easiest to explain that by just doing a 1 unit change in x. What does that correspond to in y? And in this case, a 1 unit change in x corresponds to a 1/2 a unit change in y, which is why this slope here is 1/2. So that's slope. Hopefully that made sense. Again, if you didn't understand this quick calculation that I did, we'll be covering that in its own video in more detail. So the other half of this is this intercept, right? And we mentioned in the last video that the intercept is what is y when x equals 0. Or conversely, where does the line cross the y-intercept, or cross the y-axis? And so you can see in this example, right, y-axis is this line right here, and you can see that the point that this line crosses at the point y equals 2. And you can see from the equation, right, if x were equal to 0, right, if this was 0, right, if this was 0, right, this 1/2 times 0 would be 0, and we would be adding 2, so y would be equal to 2. So again, the y-intercept, or the intercept, is the point where that line crosses the y-axis, and it's also the value of y when x equals 0. So I'm going to quickly erase that so we don't confuse ourselves. But hopefully that makes sense. Again, I think it's helpful to look at this using a concrete example. Hopefully you see where this slope comes from in terms of the change, and hopefully you see where this y-intercept comes from in terms of where it hits the y-axis. So what we're going to do in the next video is we're going to figure out, so now we kind of understand, well, given a line, we can kind of understand how it relates to the graph. But what if we didn't have this equation? What if all we had was the graph? Or what if all we had were points? Right? So in the next video, we're going to talk about how we can sort of construct this equation given some data. So again, hopefully this made sense. I encourage you to go back, rewatch any parts you're confused about, and as always, please reach out. Thank you.